Welcome to Year 7 Science. My name is Gabrielle, and this is Lesson 5 in our unit on Science at Work. In this lesson, we'll be learning about measuring mass. So what are our lesson objectives for today? Firstly, to understand that there is a difference between weight and mass, to conduct a measuring experiment, and to estimate mass and calculate a percentage error. Let's begin with a starter activity. Match these different types of scales with the correct label. So I'd like you to write the numbers 1 to 5 in your notebook, please. And then next to each number, write the name of the kind of scale that you think it is. So we've got all pictures of different scales here. What is each type of scale called? Match the numbers to the names in the boxes. So go ahead and pause the video now and complete that activity in your notebook. When you're ready to check the answers, restart the video. Welcome back. Here are the answers to our starter activity. So number 1, this is a picture of a mechanical scale. This is a kind of scale you might see in your bathroom, for example. Digital scale, number 2, this is what you might use in your kitchen. Platform scales, you might see this at a vet surgery, for example, for measuring large animals. A hanging dial scale is number 4, and micro scales, number 5. Let's do another part of the starter activity similar to the first part we've just done. I'd like you to think about the mass of what kind of objects could be measured with these scales. So for example, number 1, we talked about these as an example of a bathroom scale. So what or who could you measure with these kinds of scales? So again, write the numbers 1 to 5 in your notebook and write down what you could measure with each of these kinds of scales. Pause the video while you complete this activity, and when you're ready to check the answers, restart the video. Welcome back. Here are the answers to our starter activity. The mass of what objects could be measured with these scales? Well, number 1, you could measure the weight of a person. Number 2, the digital scales, you could measure the weight of cooking ingredients. Number 3, these large scales here, you can measure a large parcel or a box or perhaps a dog at a vet surgery. Number 4, you can measure a suitcase or bag. Number 5, the micro scales, you can measure jewelry, precious gems, or medicine ingredients such as powders and pills, for example. So let's get into the main part of our lesson today, measuring mass. All substances have mass, even the air. The standard unit of mass is the kilogram, but other units can also be used. For example, the mass of precious stones, such as diamonds, is measured in carats. 5 carats has the same mass as 1 gram. The difference between mass and weight. To an astronomer or physicist, the terms mass and weight are completely different things. Mass is a measure of how much matter there is in an object or substance. Weight is a measure of how strongly gravity pulls on that matter. If you were to travel to Mars, your weight would change because the pull of gravity is weaker than on Earth. However, your mass would stay the same because you are still made up of the same amount of matter. So you can see in the diagram here we have a person on Earth, mass 50 kilos, but the weight is 110 pounds. Now, put the same person on Mars and their mass remains the same, but their weight is 42 pounds, less than half of their weight on Earth. And that's because the pull of gravity on Mars is much less. So let's take a look at this video now about how to use digital scales. You're welcome to take notes if you want to. You will do your own experiment with digital scales later in this lesson. Let's watch.
Hey everybody, this is Marie of Humblebee and Me, and today we're going to be looking at how to use a scale. So, I've got this little scale here. I got it on Amazon. It's quite inexpensive. It weighs down to 0.1 of a gram, which is a level of precision that's really nice when you're making body products, but not necessary for things like baking. And it goes up to 2 kilos, which is a nice top range for most of the things that we'll be working with. So to start with, you'll need a vessel to weigh, in this case, our beeswax into. So I've bought some of these in the past, and so these are cute little sort of silicone weigh boats. They're light and they're flexible. I find I don't actually like them that much though, because they are so light that they tend to float when you use them in a water bath, especially if you don't have much in there. And if you're using a fine powder, because the inside of these cups has just a little bit of texture to it, the fine powder tends to stick in there, and so you lose some of it. So I tend to use little glass measuring cups or prep cups, which are really inexpensive at kitchen stores and easily available. So the first thing we're going to do here, turn our scale on. It'll register at 0 and in grams. You can cycle through using the mode button to choose ounces or pounds or kilos if you wanted to, but I'm a big fan of grams, so I'm going to leave it there. So we'll start by popping that on there, and the first thing we'll see, of course, is that it registers the weight of our sort of weigh boat. But we don't really care about the weight of this bowl, so we're going to hit the tare button to reset it to 0. So now we can start weighing out our ingredients. So I'm going to aim for 10 grams of beeswax. And as you can see, this beeswax is some that I hacked off of a larger block of beeswax with a knife, and so we've got lots of different sizes of pieces here. And so it would be really hard to accurately measure this beeswax out by volume. So that would be with a tablespoon or a teaspoon or something. So we're going to shoot for 10 grams here. All right. So there you have your 10 grams of beeswax. If you're going to add another ingredient, what you do is sort of hit the tare button again, reset it to 0, and add something else. Now, if you're new to weighing things out, or if you are really playing by the rules, you really should use a new weigh boat for every ingredient and then combine them. I, on the other hand, like to play fast and loose and generally measure everything into the same container and just be really careful, which is where these little guys come in really handy. So these are just disposable plastic pipettes. You can get them for just a couple cents a piece. And I'll use these to measure out my liquids, because then I can add them a drop at a time, and it's much easier to ignore the fact that you should be using different bowls for each ingredient. So I tend to label them here with a felt pen so that I know what each one is for, and then I'll use an elastic band and just attach this to the side of a bottle of oil so that it always sort of lives with the oil that it's used for measuring, and then just add drop by drop by drop until I get the amount of liquid oil that I want.
Okay, so now we're going to go ahead and conduct an experiment called estimating mass. For this part of the lesson, you will need a set of digital scales. Read the instructions carefully, then carry out your own experiment at home. There are sample photos of a teacher carrying out the same experiment, so you can compare your results with the teacher's. So let's look at the materials that you're going to need for this experiment. Digital scales, a pen, a banana, a jar lid or some kind of container that you can weigh some ingredients in, a teaspoon, a watch, a 100 ml beaker, a glass or measuring jug of some kind, water, and sugar. But don't use icing sugar, use regular table sugar. So I'd like you to follow the instructions on the next slide now to measure the masses of the items in this table. But before we do that, you'll need to copy this table into your science notebook. So copy it just as you see it on the slide, putting your items in the column on the left. Then the next column should read estimated mass, measured mass, and the difference. So we'll talk about what those things are in a moment, but for now I'd like you to pause the video and just copy this blank table into your notebook. Okay, so let's go into the procedure now. Step 1 is to estimate the mass of each of these items in the table. The pen has been estimated as an example. So I've estimated the pen that I'm going to use in my experiment to weigh 5 grams. Now, your pen might be a bit different to mine, and of course you will have a different watch and a different size banana. So I'd like you to just have a think about what your items weigh, what their mass is, and go ahead and write those numbers in grams in the second column, which says estimated mass. So pause the video now while you do that, and then when you're ready to go on to the next stage, restart the video. Welcome back. So as you can see, I've filled in the first column of my table of estimated mass. So I've estimated the pen to weigh 5 grams, the watch to weigh 20 grams, the banana 50 grams, 100 mils of water 100 grams, and 2 teaspoons of water 10 grams. Oh, sorry, 2 teaspoons of sugar 10 grams. So now we're going to go into the measuring, the weighing part of the experiment. So this is step 2, and this is where you are to measure the masses of the pen, the watch, and the banana on your digital scales. Once you've done that, I'd like you to record the mass in the table for each item. So you can see that my pen weighs 6.1 grams, the banana 244.7 grams, and the watch 56.4 grams. So pause the video now while you conduct your measurements and put them in your table. And when you're ready to check the answers, restart the video. Okay, so let's go ahead and do step 3. So this is where we're measuring the water and the 2 teaspoons of sugar that are in your materials list. So the water and the sugar cannot be put directly on the scale weighing pad. First, you will weigh the sugar using the jar lid or a small glass bowl as a container. So you can see I've got a little ceramic bowl there that I'm using to measure my sugar. So you place the jar lid or your small bowl on the scales and you press the tare button. So you can see that after I've placed my bowl on the scales and pressed the tare button, the mass registers as 0. Now I've gone and put my 2 teaspoons of sugar into my little bowl. And so you can see the final weight of just the sugar, not the bowl, is 11.6 grams. So pause the video now and complete the same steps for measuring your sugar and write the weight of the sugar in your table. When you're ready to go on to the next stage, restart the video. Right, so let's go on to stage 4, which is to measure the weight of the water. So I'd like you to weigh the water using your beaker or glass measuring jug. You can see I've got a little plastic measuring jug that I'm using, which has got 100 mils measured on the side. It's a bit hard to see that in the picture, but it's got a little line that says 100 mils, which I use as a guide to know that I've put 100 mils of water in my container. So you follow the same procedure as you did with the sugar. You place the beaker or the measuring jug or whatever you're using on the scales, and then you press the tare button so it brings it back to 0. Then I poured some water into the beaker, into my jug, and I looked on the side of the jug and made sure that the line of water reached the 100 mil mark. Now, don't forget to read the line of your jug at eye level. Remember the parallax error. So to avoid the parallax error, make sure you're looking at eye level. And then once you've done that, it's reached 100 mils, you record the mass in the table. So as you can see, mine reads 90.8 grams. So go ahead and pause the video now while you complete stage 4. And when you're ready to look at the answers, restart the video. Welcome back. So here are the answers to my measured masses. So your figure is going to look different because you've got different objects than I do, different size objects and so on and so forth. So what you need to do is compare now your estimated and measured mass results with the example below. So my pen, I estimated to be 5 grams. It actually weighed 6.1 grams. So that was pretty close. I estimated the watch to be 20 grams, but it was actually more than double the weight at 56.4 grams. So that was a little bit out. The banana was a huge difference. I estimated to be 50 grams, but actually it was 244.7. And it's almost 5 times what I thought it would be. The 100 mils of water is 100 grams, and I estimate it to be 100 grams, but it actually measured at 90.8. And my 2 teaspoons of sugar I estimated to weigh 10 grams, but I was pretty close with the sugar at 11.6. Okay, so now let's go on to complete column, the last column called difference, and I'm going to explain to you how we're going to do that now. So we're going to be calculating the percentage error. Determine the degree to which your estimates were incorrect by calculating them as a percentage error. So for each item in your table, calculate the percentage error using the following formula. So we've got difference in grams times 100 divided by the measured mass equals the percentage error. So let's go back to our table and do an example. So the difference between the pen and the estimated mass of the pen and the measured mass was 1.1 grams. So I multiply 1.1 by 100, and that gives me 0.11, which is basically 11%. So it's an 11% difference between the estimated mass and the measured mass of the pen. So following the formula provided on the next slide, and you can pause the formula on this at this point if you need to, and copy it down, calculate your percentage errors for your estimated mass and measured mass. And when you're ready to check your answers, restart the video. All right, so this is what I came up with. So we got the pen, 5.5 grams and 6.1 grams. Sorry, my percentage error was 18%. I mixed up the calculations. My apologies for that. My watch percentage error was 64%, the banana 79%, 100 mils of water. I actually underestimated that, so that's why it's a negative, and 2 teaspoons of sugar, 13%. So you can see that I was closest in estimation for the water, but the biggest discrepancy was in my estimation of the weight of the banana. So that brings me down to our valuation questions now. So you'll need to complete these in your notebook. And of course, because you have different estimates and measured masses than I do, this will give you different answers for your percentage error, but that's perfectly okay. So evaluation questions. This is an important step. When doing experiments in class, you are often required to write a report of your experiment, including the results. At the end of your report is usually an evaluation section where you discuss what went well with your experiment and what didn't work so well, maybe with an explanation as to why you think that was the case. For this measuring mass experiment, you will answer the following questions in your notebook. Number 1, which was your most accurate estimation? 2, by how much did your least accurate estimation vary from the measured mass? And 3, is it easier to estimate larger or smaller masses? Explain why you think this is the case. So go ahead and answer the questions in your notebook now, and when you're ready to check the answers, restart the video. Welcome back. Here are the answers to the evaluation questions based on my experiment results. So for me, my most accurate estimation was for the water at 100 grams. The real measure was 90.8 grams. So it was only out by 9.2 grams. So it wasn't too bad, less than 10%. By how much did your least accurate estimation vary from the measured mass? Well, the least accurate estimation was the banana, where the actual measurement was 244.7 grams. The difference was 194.7 grams, or a 79% error. And question 3, is it easier to estimate larger or smaller masses? Well, it's smaller are easier to estimate. This is because the methods used to measure mass, such as weighing, become less accurate as the size of the object increases. So as the object gets larger, we find it very difficult to accurately guess or estimate what the mass of that object might be. So it's much easier to estimate, for example, a pen than it is to estimate the weight of an elephant. All right, so let's do one final learning check before we get to the end of our lesson today. Here is a problem. Audrey measured the mass of a beaker of water to be 235 grams. She tipped out the water and measured the mass of the beaker to be 110 grams. A. What was the mass of the water in grams? B. Express the mass of water in kilograms. And C. How could Audrey have improved the procedure of her experiment to achieve a more accurate reading? So pause the video now and do these answers to your questions in your notebook. When you're ready to check the answers, restart the video. Welcome back. Here are the answers to our learning check. Audrey measured the mass of a beaker of water to be 235 grams. She tipped out the water and measured the mass of the beaker to be 110 grams. A. What was the mass of the water in grams? Well, this was 125 grams, which is 235 minus 110. B, sorry, that should read B. Express the mass of water in kilograms. So in kilograms, it's 0.125. And how could Audrey have improved her measuring procedure? Well, what she should have done was what we did earlier in this lesson, was to use a set of digital scales and the tare function. So she should have measured the mass of the beaker first before filling it up with water and making sure that she tared the weight of the beaker so that she could accurately measure the mass of the water that she filled it up with. Okay, did you know? The invention of the spring scale is credited to Richard Salter, a spring maker in England in the late 1760s. After his death, his nephew George took over the manufacturing of spring scales and other types of scales, and the Salter scale is still in existence today. So here's an old advertisement for the Salter, George Salter and Co. Spring and Scale Company, showing all the different types of scales and springs that he manufactured. Well, that brings us to the end of Lesson 5, Measuring Mass. Thanks for watching. Don't forget to check out our website, www.voyagerschool.com.au, for more valuable courses in more subjects for high school students. See you next time.